Hello and exam 1 review. Can't be excited for that one. Anyway, you wanted your exam in your infinite wisdom. So here we go. Let's talk about all of this stuff. So exam 1, chapters 6 and 7. So for chapter 6, we are talking 6.2 through 6.7, and then chapters 7.1 through 7.3 sections for chapter 7. You're looking at the 10 problems and 80 to 85 minutes. That's hour 25. To solve those. So technically you have about 8 minutes per problem, which is a lot, but again, time to check, time to think, and so on. During the exam, no bathroom. If you need to go before, then once you're done, and bring some liquid, some sugar, right, and stuff to keep your attention. I'll have the puppies and kittens over there to diffuse the situation. Riot photos, that's what you want? All right, fine. Riot photos. So that will be the material. And now, if we are going to look at individual topics for the exam, you have the disc plus washer. So this is the same. Oh, sorry. Area between two curves. Holy nightmare. Area between two curves, which is just when you have the integral of f minus g, right? dx. Now you have disk plus washer, and that one would be f squared minus g squared dx of some sort. Then you have the shell. Well, this one has a pi in front. 2 pi. I did p of x, h of x. I understand that some of you just say, okay, x f of x, but this one has advantages as well. Length of curve, which was L equals integral of the square root of 1 plus f prime squared. So it's not a 12, that's a derivative. Squared dx. Surface area revolution, which was S equals 2 pi integral of f of x times the square root of 1 plus f prime squared of x dx. So that was the revolution. And finally, we have physics. And for physics, guys, you have number of things, mass. Number 2 is the work. And then number 3, work by spring. That's good enough. Moving to chapter 7, you have your exponential / logarithmic integrals and derivatives. So derivative / integral. 7.2 exponential models. This is where the word problem. Also for physics word problems, so at least 2 word problems. Exponential model, and now remember it's for limit, derivative, or integral. You can go back in your lecture notes on video to see these done. We did the population, we did, if you remember, Doramad, we did Advil, I think, and population, and what else did we do? Did we do money maybe? I don't know. We did a whole bunch of stuff. And finally, hyperbolic functions. where the important stuff is that sine hyperbolic x was defined as e to the x minus e to the minus x over 2, must know that one. Cosine hyperbolic x was e to the x plus e to the minus x over 2, must know that one. And then prove identities, and then derivative plus integral of hyperbolic functions. And for derivative, it's mainly chain rule, and for integral is mainly u sub, obviously. So that's the entire integral. I'm going to say here in green, 8.1 is very useful. So 8.1, very useful. Yeah. So 8.5 is very useful if you do 8.1. There will be no 8.2 on the test, right? 8.2 is integration by parts. That's going to be on exam 3. Your chapter 8 and chapter 9 are on the exam, exam 2. So exam 2, chapter 8 and chapter 9. Now you're only focusing on 6 and 7. So out of what we covered so far, you guys are only focusing on all of the lectures up to 8.2.
Can we use integration by parts if it makes it easier?
It will not pop up. It cannot pop up at all, because if you're using integration by parts, that means that you cannot use any other method.
So we're not allowed to use it on the exam?
You can't.
Okay.
That's the trick. You are not able to. So if you use it, it will give you the wrong stuff. You will use it in the wrong way. And
okay.
Yes.
Your notes, are they in files on Canvas?
On Canvas.
Okay.
Yes, all of these PDF, and I'm going to add obviously whatever we do now on this. So the notes should be all up to date up to 8.1. So I'm going to add the 3 that we did today, and that should be all up to date. Any other question, concern regarding so exams will have every other page blank. It will be printed only one-sided, so that you can use the other page as a scrap paper. And the last page can be used for art. If you want to draw something, write a poem or a short story or something to, make my misery less miserable, right? It puts me in a good mood, and then
better grade.
Math is math. If it's wrong, it's wrong. It just puts me in a good mood. I like you better.
So we're not going to have any of the pumping or lifting?
Should I add that?
Please no. Just making sure.
So with the physics problems, it's specifically the spring problem, mass problem, and work problem?
Yes.
Okay.
Unless you want more.
Also, it's funny that you say math is math, because that's just a line that gets tossed around by the production team where I work. It was just some stupid addition problem that they were having, and one of my coworkers, Roger, was screaming at one of the Portuguese higher ups because he kept getting the same problem wrong over and over again when they were adding it up on the batch record. And Roger just ended up screaming, what are you talking about? Math is math!
Math is math, exactly.
Apologies.
Yes. So these are the problems. Do you have any questions that you would like me to talk about, work on? What you got?
So, yeah, I was talking before. They have the transformations put into the integral for shell and disk or washer method.
Yes.
So I was wondering if we could get an example of washer and shell with the transformations put into the integral and like rotating around each axis just for reference?
So shell is the good one for that, for instance, because you have that P of x that I talked about. So if you have a shell problem and you are rotating around, let's say, x equals to 2, and you have the, let's say you have a square root function that started there, but that square root obviously is going to be square root of x minus 2 because it's shifted to the right.
Like what if the function was like for like square root of x minus 4 or something? Just to
Doesn't matter.
so
Okay.
Just so that we can see it in the integral.
So that's at 4, that's at 2, square root of x minus 4. Right? So there is now, we have the volume to be 2 pi integral, and let's say you are going from 4 to, let's say, 8. Let's say that's what you want. It doesn't really matter, but let's say that's what you want. So now you have your position. Position is measured from the axis of rotation to the location where the representative rectangle dx is, right? So this is where the dx is, and this is going to be your p of x, right? Now the formula that we used was, come on, there we go, that I used, it was p of x, h of x, dx. And the reason why I used p of x is because if the axis is shifted like this, then that axis becomes, see, you have extra 2 units that if you used x for those, just x as it was listed in the book, then you would have an issue that you are going to have an extra 2 units that you don't need. So to set this one up, it will be 2 pi integral, and you want to go from 4 to 8. So if you are not shifting functions, then the limits are the limits that are on the picture, right? And let's say that's the one you wanted to rotate, right? So if you are rotating that around the x-axis, then your limits are 4 to 8. And here is your p of x. Your p of x is now 2 minus x, because you have to take away 2 units, right? And then you just have your regular square root of x minus 4. So no shifting of any functions or anything like that. The shift of the rotational axis is within the p of x. And that's the part. Now, integrating this obviously is going to be the standard integration. Nothing special. You asked me mainly about to set this thing up. Now, the reason why I am showing this is because apparently MyMathLab is very stingy on that you actually have to put this in to progress and do the problem. Much better gig is to shift the function to the left. And when you shift the function to the left, the 2 units, the axis of rotation will collide with the y-axis, and then you just do the regular basic problem. So on the exam, I would actually prefer you guys shift the function, because that's much easier, right? If you are to take this and you just move everything to the axis and have it, there, in that case you have the, right, if you move it to the axis and then you go from there, then you are rotating around y-axis, and the problem becomes, now since you moved everything 2 units, it becomes 2 to 6, right, on the graph, and then you have your 2 pi integral 2 to 6 instead of 4 to 8, and you just have now x and then square root of x minus 2, because it's no longer minus 4, it's now 2 because you shifted it to the left. So these 2 integrals are supposed to provide you with the same answer when you integrate, right? But you see that the second integral is much easier to deal with because now both of these, just in case, both of these use u sub. So this one over here, u is equal to x minus 2, and then du is equal to dx, and then you have to do that back substitution part where x is equal to u plus 2 to solve the integral. So if you get stuck on this, you know what to do. So that's the shifting. The shifting is simply you are adding the piece that just moves within that p of x, right? Now for washer, it's much harder because you have to actually modify the functions inside the washer, and that's again, are you shifting stuff to the left or are you shifting stuff to the right? And you have to subtract the unit within the squared terms. If you give me the particular problem, we can take a look.
My stuff is a mess right now, but I'll find one.
So we can take a look. Okay, well, you find
Most of the problems in 6.3, it made you put it in integral form for the disk or washer method and the shell method, and then solve it, and it would have you put the transformations into the integral for each one.
so most of, okay, but I'm not sure if actually your quizzes would have them.
I don't know. I feel like they would ask you to do it in either method. I don't know if they would care if you put it in a form, but just in case.
Yeah, the most important part is obviously to get the right volume at the end. Like that's the goal, right? That's what we're looking for. But again, much better way is to get the function shifted rather than go through row to disk. And it shouldn't be majority of problems, right? It should be just some of the problems, maybe 10% or 15%. The way you're saying it sounds like it's every homework problem had it.
It wasn't in those sections, it was most of them.
Really?
Yeah.
Yeah.
That had a shifted axis?
Yep.
That's evil.
Okay, so really what you're just doing, I know you're shifting the graph, I'm just confused about how. So actually, no, I take it back. So I get the x minus 2, because like
2 minus x.
that's what I was gonna say. I don't get that. 2 minus x, why is it that way?
Because it's the difference that you worry about. You see, your axis is at 2. The p of x measures the x value. So over here, you have 2 units. Let me use a different color. So I don't even know what to use. So from here to here, you have 2 units. And from here to here, you have let me see how I'm going to put this. So should I put oh, there we go. Ha. From here to here, you have x units. Right? So to shift everything to the left, this difference over here is x minus 2, but you're moving everything to the other side. So it's 2 minus x.
Okay, because you're going to the right?
Because you want to measure your p of x. Your p of x is always in between the axis of rotation and the dx.
Right. Okay.
Do you have the washer one? Because those are much worse.
So
That one I have to actually break my head over to.
it's the region bounded by y equals x squared,
Okay?
y equals 16,
Okay?
x equals 0.
Okay?
We're rotating around x equals 4.
Okay, so to graph this one, I'm going to draw x squared. I'm going to draw the line at 4 for rotation. I'm going to draw y equals 16. Because it has to be, since this is x squared, then 4 squared is 16, so they have to intersect there. And what else do I have? I have x equals 0. So x equals 0, x equals 16. Do they have, they don't, okay, so it's this piece, because they don't say y equals 0. It's this piece here. And, well, this is also shell, it's not disk.
They have you put it in both methods.
Uh-huh. Okay.
So it would be like washer method, I guess?
Yes.
Yeah.
But it's gonna be, because it's a y rotation, right? It's a y rotation, so it's gonna be dy, and that's, so rotating. So if I want to use the disk, I mean the washer, if I'm using a disk or a washer and I have a y rotation, because it's x equals 4, that's a y rotation, then I need the dy, which means that I have to swap my y equal x squared, I have to swap that into x equals square root of y, which is this piece here. And if I draw my representative dy over here, okay, so now how do we set this up? Okay, so what the formula? The formula for the volume is going to be pi integral a to b of f, well, it's actually c and d because we're using y's. So c to d of f of y minus g of y, all of those squared, each one, and then dy. Now, I just have to think a little bit because it's on this side. So dy is gonna go 0 to 16. So volume is pi, it's a single pi because we're doing the washer, integral, and then 0 to 16 because it goes from the bottom all the way up. And then now the one that is further away is going to be the x equals 0, but because it's 4 units away to the left, I believe that this has to be 4 squared because it's 4 units away minus the square root of y squared dy. I think this is it, because you are measuring now far away minus close by. Far away minus close by, and you're going to the left. So you are 4 units out, and then minus the square root of y to measure the top and the bottom, and then go 0 to 16 on the limit. I think this is it.
So
That looks right.
The way that they would put it is pi, and then in the pi on the outside. So 4 squared minus, and then in parentheses 4 minus square root of y quantity squared.
Ah, yes. because that one is also shifted. I shifted this one. See, I did do 4 minus 0 here, but I didn't do 4 minus over here.
Okay.
Yes. See, I don't do it this way, so that's why.
It doesn't make any sense to do it this way. But
It doesn't, because it's better. So yeah, 4 minus y, root y. I don't like this. I shift the function, it's much faster and easier than dealing with this. So it's because you are measuring, again, the same thing like we had earlier. I had that 2 minus x. Now you have whatever the axis shift is, so that number minus the original. So you know what? I'm just going to write over here for this one as 4 minus 0 squared, so you know that, because this over here is x equals 0, so you have 4 minus 0, and this one is x, which is root y, so 4 minus y, because you have to shift it to the, again, this is absolutely crazy to do this way, because it's so much easier. If you shift the function, you just move it. You just put that plus 4, because you shift it to the left. Just put root y plus 4, and then you just do the regular boring derivative, the regular boring integral from the section, and you're done. Now, shifting in this way just introduces more mess. So I'm not going to ask you guys to do it this. If there is a shift problem, you can shift the function and be done in 10 seconds,
I'm
right?
just going to skip those problems when it tells you to do it on the homework, but like if it shows up on a quiz, I just wanted a good example to be able to look at. So
Yep.
just in case they ask for it.
Mm-hmm.
Left one?
Drop top.
Okay, what else? We have the length of the curve. You know that evil trick, right? The length of the curve when you do the plus half, minus half, and all that stuff. We did that in the courtyard.
I only have one question.
Yes.
We're not going to do any problems where it asks us the force to pump the liquid out of the container.
No, unless you want to. You want to make it.
But we will have like the rate of change one, or like when it, like if like a cylinder or whatever.
You're going to have the mass and the density and the work for spring.
Work, that's what it is.
Yes. What's that?
I really don't get the transformations. It's just not clicking, but I'm just gonna sit on it for a little bit, and maybe it'll make sense.
It's the axis where it is minus the function, the original one.
Oh.
Wait, so now
Oh, it's always that. Oh.
It's just a
Well,
minus.
why didn't you just say that?
I thought I did, but apparently I haven't.
You didn't say it that simple.
4 minus 0, 4 minus y. I said whatever the original functions are, the axis minus it. I didn't say, okay, fine. You win, I lose. End of discussion.
You're such a good man. You know better than to argue with a woman.
I actually don't. But that's fine.
Right there. Case in point.
So, are we the only lab group left?
Yeah, we're all in a group, I guess. I don't know if you said at the end of last class, but people were like sharing numbers for lab group.
Oh, that's what that was? Not here.
Wait, mine is.
So do you have any other questions regarding, so you have the proofs in hyperbolic, which means for proofs you ship everything into e's, right? And then you work algebra of e's. You have the derivatives using the chain rule and integrals using the u sub for the hyperbolic. And then I mean, if you just take the derivatives of all of your integrals and make sure that you integrate it correctly, right, you should be able to spot the issues. And please do that. Okay, let me write in blood over here on top. Practice on MML
what's your name?
chapter
That's it. These
6
numbers.
post
7, 8,
test,
7, 7. Yep.
chapter 7 post test. So those are the sample exams.
Gotcha.
Sample exams, and you find those sample exams in MyMathLab. When you change the assignments, the homework, you change it into quizzes and tests, and then this thing pops up. You scroll down, and don't forget the quizzes, obviously, daily quizzes to practice. Now I'm going to have office hours the whole week if you can make it, obviously, and then you should also hang out on Discord and post questions there, right? If you have any math questions, go in the math section of Discord. It's quiz trolling or whatever it is. So naughty memes, or keep the math in the math, and then memes are separate.
I have a question about area between two curves.
Okay.
If I draw it, will we have any that are like where it's something like this, where part of it you have to do this way and part of it you have to do this way?
No, you should not have that situation actually happen ever. You can't split the function so both of those are satisfied.
Yeah.
Unless you,
Like square root absolute value x.
absolute value x and squares, that's not a problem. If you have area between two curves with, let's say, absolute x and square root of x, well, that's definitely not going to be a problem because you only have one-sided. Probably what you think is when they crisscross, right? So there are two, where one f minus g and then g minus f in the next one. That's perfectly fine. I think I gave you guys sine x and sine 2x as a homework example, where you were supposed to draw sine x and then sine 2x. And you can see that you have the red one and you have the blue one. So the red one was sine 2x minus sine x in the integral, and the blue one was sine x minus sine 2x in the integral.
Good example.
So that's the one. You can achieve this in many other ways. X cubed. No, yeah, x cubed. Let's say x cubed minus 1, I believe, and an x, let's say. So I think. So x cubed should be graphed. I believe x cubed graphs this way. Yeah. And then the x graphs that way. So for the red side, you have x cubed minus 1 minus x. And for the blue side, you have x minus x cubed minus 1. So it is perfectly fine. And it's perfectly fine to rotate them as well, because if you rotate them, right, you just put the squares on each one. So they're fine. Should not be freaking you out.
If we have to rotate something like that, let's say we rotated that function with both of those boundaries included, would you subtract the areas in that case?
No subtract. You mean to rotate?
Yeah.
No, you would have to rotate this away from the axis of rotation. That axis cannot go through the shape.
All right.
So axis would have to be here, and then everything has to be shifted up or mess with your
So
4
that
minus.
stays all on one side of it.
Yeah.
Because
But
I know that we had we had a question on the lab, but like I think we all came to the same consensus. That
you cannot have the axis within, because
Well,
you
no,
would
there's
have the
symmetry.
overlapping. Yeah, you would have the overlapping volumes, and that would not be bueno for the calculations.
It's symmetrical.
you could just 0 to blah and then multiply by 2.
Mhm.
But what I wanted to ask, so when doing the translations, if it's an x-axis translations, you just add to all the x's of the equation, and then it's y-axis, you just add to the function itself. So in the first case, okay, I'm just trying to make sure I
Sorting it in your
the
head.
book does such a bad job of explaining it.
yeah, it
I hate
does.
it. I'm just
So
trying to keep up while writing notes and like I just
I said
That's
Larson
the thing.
book. I said Larson 15,000 times. You can find it for $15. Well, I heard that there is a free, that the actual publisher is giving the free PDF on edition 10. You can find a free book, edition 10, legal, not pirated, all right? Edition 10 for free. I told you to buy 7 because the 7 is the one that I usually suggest because that's the one I learned from, and everyone swears by that book. Probably they improved even more after that, but I know you can find a 7 for $15.
when I was working through it with a couple of my roommates a couple of years ago, so I was just trying to pick up some free calc because I was trying to go to Forest County Community College back when I was up in Persephone. But I was the Stewart. The essential calculus. I thought they did a good job with that. I just got hung up because I wasn't really getting, and this is back to like early limits, like this is 5 years ago, but this is back when, or this was for limits and epsilon and delta testing. That was just like, for some reason I just couldn't grasp it, but taking calculus last semester like really helped me. At least having a teacher explain it made it make more sense, which it was really easy to apply that to derivatives because that's exactly what it is. Like, hey, we're going really small.
Can we go over one more problem?
Sure.
Lab solutions today or next week?
Next.
Next week. Oh, okay.
Remember that trough problem
Because nobody had anything.
you were talking about?
Yeah. I'm
Oh
waiting.
yeah,
Yeah,
that's
no one knew about it like anything.
that problem is.
Is that from the lab or
No, this is actually not for the exam because it's too spicy, but it's a really cool.
was this a trough?
Yeah,
The real drag. That's Round Valley.
Tomorrow.
What's the meeting point? You said north.
North Picnic Point. Yeah, north.
Picking point.
Yep.
Okay. All right. See you guys later.
Yeah.
Take it easy.
Bye.
So if you look at this thing, right, and it's a half of a barrel, let's say, cut, right? Half of the barrel cut goes like that, goes there, and then it has the same thing going, right? You're going to have the level of liquid somewhere, what you decide, and you want to pump the whole thing out, right? So you have the liquid underneath. What's important is to look at the side over here and say the liquid is up to, let's say, this level. So if this is length L and you have radius R, the trick is to draw these lines for a triangle like this.
Oh, and then you always have the base.
And then this one is R, and this one is R, and this height over here is also R, but what you care is for the height H between these two. So now you can isolate this picture that goes like this. So it goes like this, where the whole thing over here is R, this is H, and this is clearly R minus H, and this is big R. And this is going to be the length that you don't need this length of the water because you care about the area. No, you do need this length over here, so we'll call this lowercase l, I guess. Lowercase l. So we need L. Oh, okay. So not gonna use this H. I'm gonna use the Y. Sorry. I'm gonna use Y. Use Y, Y, and Y because we want the L in terms of Y, and that will give me the area in terms of Y because area will be L times the big L. Big L is just the length of the tank, and the small L, well, actually it will be 2L, sorry, 2L, because we are calculating one side is L, and the other side is, so that's L and that's L, so it's 2L across. There we go, much better. So now when you take a look at this picture, you have a Pythagorean theorem here, which is capital R squared is equal to L squared plus R minus Y squared. Now, capital R is a number you know, because that's that's the radius of the trough, right? So you solve this for L. L is going to be the square root of capital R squared minus R minus Y squared. And then you work that out to get R squared minus, over here when you square it, you get R squared minus 2YR minus plus Y squared. And then when you cancel, you get that L is R squared minus R squared cancels. And you just get 2YR minus Y squared. Again, this is not for the test, this is just for fun.
Right.
And we have L. So now, this is a variable, leave it alone, and this is going to be a number given. Because that's...
The changing length of the water coming down the trough.
So radius is given, radius is, let's say, 2 feet, right? So you know R is 2, let's say. So the only variables you have L, which changes with the height, Y. And once you have that, you have that the area in terms of Y is given as the capital L. So now you have 2 small l times the capital L. So you have 2 square root of 2y capital R minus y squared times the big L, which is, I don't know, 6 feet long in terms of the barrel. So now you have this, and then to calculate the work done to pump the water out, you have your integral, and then you have your rho and your g. You have your A and B limits, right? Depends on how much water you're pumping. And you have your 2L square root of 2y r minus y squared times the distance, how far you go, minus y dy. And this is height to pump to, and L is the length, and R is the radius, and then you have the standard. So Y is the variable. I guess we use the C and D, not A and B, because these are vertical distances. So C and D is the water level, right?
What was
C-
the lowercase l in that again?
Lowercase l was the half of the water that, see, this, if this is full of water and radius is 2, then the length of the water is 4, right? But then as you start pumping the water down, because it goes on these sides, right, the water level decreases and it gets shorter and shorter and shorter as it drops down. So it depends on the height y. So I'll upload all of this, but again, this problem is not something that is going to be on the exam. It's just for the fun, because we can.
They had some stuff that was kind of similar to it, but not nearly as many different steps, substitutions.
Yeah, I like that it's just calculating the surface area and then you integrate in the height.
Depends. And just shut this off. Bye.
They had one